Hello, so this is a video about natural computation. We are going to address some questions and answers. So the first question is the following. Consider a genetic algorithm in which selection is implemented using the roulette wheel method. How can the creation of a super individual affect the genetic diversity of the population? So I stick this question into the notebook LM and we are going to see the video that he created to explain and try to answer this question. And the video is the following.
Hey there, welcome. Today, we're going to crack open a really fascinating puzzle from the world of AI. It's kind of like a detective story about evolution, random chance, and, well, the hidden danger of being a little too good at the game. Okay, this question right here, this is our central mystery. It sounds a bit complicated, I know, but trust me, by the end of this, you're not just going to understand the question, you'll get why the answer is so important. So let's unpack this thing piece by piece. All right, first things first. To solve our puzzle, we've got to understand the rules of the game. And that game is called a genetic algorithm. So what is that? Well, imagine you want to design the most efficient airplane wing ever. Instead of starting with just one blueprint, you create a whole bunch of random ones, maybe 100. A genetic algorithm takes these designs, tests them out, and then breeds the best ones together to create a new, hopefully better, generation of wings. It's literally evolution, but for solving our problems. Pretty cool, right? And this whole thing, it runs in a loop. You start with that random population of solutions, then you check how fit they are. How good are they at solving the problem? From there, you pick the best ones to be parents, you combine their best features, that's the crossover, and maybe you throw in a tiny random change, a mutation, just to keep things interesting. All that creates the next generation. Then you just do it all over again.
Let me stop here because you don't do all over again because step one, we don't do it again. You just pass to step two, evaluate the fitness, and then you do the loop again. So we don't create again an initial population.
And again. And with each loop, you're inching closer to the perfect answer. Okay, so we've got our digital creatures, and they're evolving. But how exactly do we pick which ones get to be the parents for that next generation? Well, let's look at one of the most popular ways to do it. This is where our roulette wheel comes into play. Think of it like a big pie chart. Every potential solution in your population gets a slice of that pie. And the size of your slice, that's determined by your fitness score. The better you are, the bigger your slice. Then you just spin the wheel. Wherever it lands, that's who gets to reproduce. So being good gives you a much better chance. But here's the kicker. It's not 100% guaranteed. Now, in a really healthy, diverse population, this is what you want to see. You've got individuals C as the frontrunner with the 35% slice, sure, but A and B are right on its tail, and even the others have a decent 20% chunk. This balance is absolutely key because it means lots of different good ideas are all getting a chance to be passed on. But every good story needs a plot twist, and here's ours. What happens when the game produces not just a good player, but an absolute superstar? An individual that just completely rewrites the rules. This question gets to the very core of our problem. In this world of slow, steady improvement, what happens when one solution suddenly shows up that's just head and shoulders above everything else? And this is what we call a super individual. It's an anomaly, a fluke. Maybe it was a 1 in a million mutation or just a really lucky combination of genes. But for whatever reason, it's so incredibly good that it makes every other solution look like it's in second place by a mile. It feels like you just hit the jackpot way too early. And wow, just look at the wheel now. This is the new reality. Our superstar has a monster 85% slice. All those other potentially awesome ideas, they're all crammed into that tiny little 15% sliver. The game isn't balanced anymore. It's completely and totally dominated. And this brings us to the final and most critical piece of our puzzle. The unintended and frankly dangerous consequence of this superstar's rise to power. Before we get there, we need to understand this term, genetic diversity. The simplest way to think about it is that it's the algorithm's creativity. It's the entire toolbox of different ideas and approaches it has to work with. This variety is the fuel that lets the algorithm explore totally new paths and keeps it from getting stuck in a rut. So let's connect the dots. It's a chain reaction, really. Step 1, the super individual completely owns the selection wheel. With an 85% chance of being picked every single time, you know what's going to happen. It gets chosen to be a parent, again and again and again. And what happens when one parent has pretty much all the kids? Well, the next generation starts to look exactly like them. The population becomes this sea of clones and near clones of that one superstar. And just like that, all those other interesting, different, creative ideas, they're gone, wiped out. The algorithm's fuel for exploration is totally spent. Genetic diversity has just plummeted. This brings us to a huge trade-off in AI. High diversity is all about exploration, testing lots of different paths to see what works. It might be a little slower, but it's way more robust. But the low diversity caused by our superstar, that leads to exploitation, just drilling down and refining that one single idea. It's faster for sure, but it's incredibly risky. And why is it so risky? Because it's prone to something called premature convergence. And this right here is the punchline. The algorithm finds a good enough answer really fast and just stops looking. It gets stuck on this little hill, totally convinced it's at the peak, completely blind to the fact that Mount Everest might be just over the horizon. That superstar wasn't the ultimate answer. It was actually a powerful distraction that killed off all the other possible paths to a truly great solution. So let's circle all the way back to our original mystery. We have our answer now, don't we? A super individual dominates selection, it floods the next generation with copies of itself, and in doing so, it causes genetic diversity to totally collapse. This traps the algorithm, making it impossible to find the best possible solutions. So the rise of a superstar, as it turns out, can be the downfall of the entire search. What looks like a massive early win is actually a hidden and very dangerous trap. Hey there.
Oh, sorry. So, about this AI generated video, I think it's quite good, and so that's my opinion.